Okay, so again, recording in the kitchen here, a little bit of background noise. Hope it's okay. I noticed here we had 44%, which is huge, right? It's almost half the class. Maybe stuck. Just did a video on that one. Let's look at this next one, 33%, a third of the class. This could be a big deal. Understanding the 3D shape of molecules with pi bonds. So let's click on this, and we'll say, all right. If we have, we're going to have to do, are they going to ask us, oh yeah, this is a toughie, yeah. All right, so they're going to say, let's suppose, I think they're saying what possibly, if we look at that bond right there and we turn that bond, well, let's read it. Examine the highlighted bond. I see it. It looks like it's planar. If that's a planar bond, select all the pictures that could show a three-dimensional arrangement if I look at this from different angles. Yeah, let's do this. So let's come over here, let's put this here, and we'll say, all right, so this thing is planar, we know that. So let's take this, and it's that, but it also has a hydrogen here, right? So this is a CH3 here, and a hydrogen here, and a hydrogen here, and it's got a plus charge on it. But so let's think about this. If we look at this straight on, it's going to look like that. If we put this in the plane of the board or the computer screen, it's going to look just like that. But if we look at it from this angle, dot, 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 right? Then you're going to have a methyl group which is close to you, and a hydrogen which is close to you, right? So it's going to be like, here's your nitrogen. Actually, let's think about it from this person's standpoint, okay? This person, and also probably should give a little more feeling here. What's going on? This is like this, maybe. Okay? That's not hair. That's eyebrows like raised up. Oh no. No, that forehead would go above that, wouldn't it? Okay, so anyhow, what we have is the nitrogen's going to be down below, right? Because that's the chin, right? So the nitrogen's going to be here. And up here is going to be a carbon, right? And you're going to have a methyl group pointing straight at your forehead. So watch this. It's going to be like that, right? And you're going to have a hydrogen pointed away from you, right? And you're going to have a hydrogen pointed at your chin, and then one pointed away from you. Okay, so that's if they're looking at it from that angle. What if you're looking at it from this angle here? Let's make this person a little bit. A little more stoic. Looking at it from this angle, it's going to look different, right? The nitrogen's going to be in front. So let's skip the red for now. Let's go up here and see if we can see anything that looks like this. So if you look at it straight on, oh, it already looks like that. Oh, the underside of it, if I flip it over. If I take this and flip it over on the other side, it'll look just like this. Right, with the hydrogens on it, of course, right? Okay, let's take this other one. Oh, this is exactly that thing right there. Oh no, there's a hydrogen missing. Nope, that's not going to be it. Okay, what about this one? This is except there's a hydrogen missing. Right, so it can't be that. And look at here. No, it can't be this because this implies that the methyl group is at right angles with that. It implies that the hydrogen is coming out towards you, but the methyl group is not. It's in the plane of the computer screen. This is super important. Three-dimensionality. We will build models for these on Monday, maybe. So this can't be it. This can't be it because if I've got a methyl group coming out toward me, I also have a hydrogen coming out toward me on the same side. I can't put the hydrogen coming out toward me on that side. That can't be it. I wonder if actually ALEKS is going to let me assume that there's a hydrogen here. I don't think so. Why would they do that? Because look, here's another one. So If this is correct, this will also be correct. But if this is wrong, this will also be wrong. But it surprises me there's only one. Let's look at the rule again and see if I'm allowed to have a hydrogen coming off of that. Let's look at the rule. Examine the highlight. It doesn't say. So I'm gonna click solve, and I'm gonna say this should be the only one that's correct. If this is correct, this will also be correct because it's just from a different angle. Let's click solve. Yep, only one. So it's not gonna let me do the hydrogen here. Okay, so let's try another. This one, super important to get your eyes used to this. Really, really important. Organic chemistry, if you don't see the stuff, you don't see the shapes, it's really hard. I mean, it's worse than that. I think it's impossible. Let's come here. Okay, so this is about this bond right here. Is it allowed to rotate? If it's allowed to rotate, all possible 3D arrangements. Yeah, so if it's allowed, it looks like it might be allowed to rotate. If it's allowed to rotate, that's a single bond right there. So there will be some rotation, right, about this bond, no problem. So we could get a couple different things here. Oh, this is weird. This could be it, right? You see, well, right? We see the same thing here. You see it? Okay, so that could be it. This cannot be a 3D arrangement because this is not 3D. There's no hashes and wedges here. No hashes and wedges. This could be it because you got rotation. If you got rotation about that bond, this thing's going to look like this. If that bond rotates, it's going to look like this. Oops, I want black, right, for that other one. It's going to look like that, right? So that's legit. That could be it because it looks like that. See that? So this is legit. This is legit. What about this one? This is not legit because if this is planar, that can't be a wedge. No. Let's make sure we're consistent with our colors here. Yeah, this could be it, right? And this could be it. Same thing. This is good, and this is good. This is good because, again, you've got your double bond, and then this, like, you see how I've got my sp3 hybridized carbon. This can be constrained to the same plane. Yeah, we need to have a conversation about this in class. If you still don't like this on Monday, no problem. We'll talk about it. You really should get a model set and try to build this so you can get it in your eyes. Okay, so we should see a yes, 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 and yes. Let's go look at that. We should see a yes, 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 and yes. And we do. Okay, that's a little fast. I'm not sure how helpful that's going to be. Bring the questions to me. Or screenshot one of yours that you thought was, and send it to me, and I'll show you why it's not. Or be ready to argue about this in class on Monday. This would be a great quiz question for Monday. All right, good luck.